The objective for this challenge is to find the tension needed to generate a designated frequency. For the second experiment, we needed to calculate the length to produce a second frequency. After doing both experiments, we did find the tension needed for the frequency and the length.
In our experiment, to get the frequency we want, we use a string of guitar, the thinnest string of an electric guitar, and to get the tension we use a bottle of water.
Using the frequency formula and the free body diagram, T was solved to know how much mass we had to add to the system.
We get the linear density of the string, and with the linear density and the frequency we want to get, we made the math in order to get the tension we needed. So we tie up the string in the bottle of water with the exactly amount of mass. Then the string was with the necessary tension, and with the finger we move the string. The string start making a frequency, and we capture the frequency that the string was making, and this was very close to the frequency we want, to the 600 hertz.
The second part of the experiment consists in changing the value of frequency for 1200 using the same values of tension and mu than the previous experiment. The formula was solved for L, to know at which point the string had to be cut in order to get the new frequency. The values were plugged in the L formula, getting a value of 10 centimeters or 0.1 meters. At the moment of generating the wave, we place our fingers, cutting the string at the given measure, obtaining a frequency of 1120 Hz.
Our error percent was really low, being 2% in the first frequency and 7% in the second frequency. However, this difference between the theoretical value and the experimental value may be due to inaccuracies of the app and inaccuracies in the measurements.
In conclusion, the experiment was a success, but as any other experiment, there were improvements one can do. First, the graphene moved while the oscillations were made, making the frequency change a little bit. We could fix it or hold it better. The distances could have not been very precise, so we could have checked the distances twice or do the experiment 3 times and get an average of the frequency. Also, the string was not the thickest one, and so the linear density was not as precise. So if you get a thicker string, you get a bigger linear density and more precise one. Then we could have used more weight to increase the tension and have a more reliable frequency. But we couldn't thanks to the fact that more weight the string wasn't gonna hold any more weight. Finally, the app was not the most trusted nor qualified one. The measurements differ a lot in a little or no time.